Have a great day. This is page number 45. The question is, what is Pyroflow CFB technology? Pyroflow is the patent trademark of famous Finnish company Alstom Pyropower, recognized worldwide as the leader in the supply of fluid-acid bed combustion system. Note pyre is Greek word for fire and flow means movement of circulation. Hence, Pyroflow system is true representative of circulating fluid bed combustion. How does pyroflow system work? The pyroflow CFB combustion system operates on the circulating bed concept. Fuel and limestone for sulfur capture are fed into the lower portion of the combustion chamber in the presence of fluidizing air. The turbulent environment mixes the fuel and limestone quickly and uniformly with the bed material. Fluidizing air causes the fuel, limestone, and bed material to circulate and rise throughout the combustion chamber and enter the hot cyclone separator. The captured solids, including any unburned fuel, are then re-injected to the combustion chamber through non-mechanical loop seal. Continuous circulation of solid through the pyroflow system provides longer fuel residence time, resulting in very efficient fuel combustion. The limestone in the fuel mixture reacts with the sulfur dioxide and other sulfur components in the flue gas and removed with the ash as an inert dry solid, calcium sulfate or gypsum, CaSO4. The relatively low combustion temperature 1075 to 1175 degree Kelvin and the introduction of secondary air at various levels above the grid provides for staggered combustion, limiting the formation of oxides and nitrogen. From the convection zone, flue gas pass through a particular particulate collection system to the stack via induced draft fans. Source Alstom, Procher Pyroflow CFB technology. In here, we can see the Alstom Pyroflow system flowchart. The oil cooler bottom ash to ash silo is bottom. In this boiler, we cannot see. The fuel gas is flowing through the boiler and it is going to the right side of the boiler, which provided the superheater and economizer. The hot cyclone is for re-inject the unburned coal or solid materials. The fuel and limestone are injected in the bottom of the boiler, and steam drum is provided in the top of the boiler. The steam is going to the superheater and steam outlet is there in the top of the boiler. Feed water inlet to the economizer and air heater is provided in the right side of the boiler, and the exhaust gas is going to the dust collector. Through the ID fan it is going to the stock. Primary air and secondary air is introduced via air heater to the boiler. And the next question, what are the major components of CFB units? Answer, refractory lined lower combustor section with fluidizing air inlet nozzles located on the floor above the wind mix. An upper combustor section lined with water valve. A transaction piece introduced a hot solid separator and re-entry downcomer that may be either entirely or partially lined with refractory. A convective boiler section which is similar to that for a conventional boiler in most cases. A loop seal also called J valve or L valve to provide a simple non-mechanical hydraulic biometric seal against the combustor shell. Primary air is supplied to the fluidizing medium while secondary air is supplied a few meters above the combustor floor to effect staggered combustion. Question: in several designs of convective passes for most CFBs, the superheater is located in the combustor ahead of the cyclone. Why this arrangement is made? Answer: to take advantages of high heat transfer rates in the region. 2. Second point: to lower the temperature of flue gas entering the cyclone so that lower temperature refractory materials may be used. Question: the design of loop seal, also called J valve or L valve, plays an important role in determining the sulfur capture efficiency of the bed. How is this true? Answer: the loop seals are large diameter refractory lined pipes to recycle elutrate bed particles. They are void to any internals but may be equipped with nozzles for admitting compressed air to keep material flowing. The solid recycled stream may or may not be controlled to help maintain in constant bed temperature, which affects sulfur retention efficiency. Question: from the process perspective, it is said that cyclone is the linchpin of the CFB process. Why? Answer: the cyclone separates the entrained particles from the flue gas leaving the combustor. The cyclone separates the entering particles from the flue gas leaving the combustor and feeds back hot solids to the combustor. The higher the solids recycle rate, the higher is the efficiency of process in ensuring uniform temperature in the combustor. The efficiency of cyclone determines the capture rate of fine fraction of the solid entering that cyclone. This in turn affects limestone utilization and carbon burnout. This is the cyclone plays the dual role maintaining the high combustion efficiency of the combustor as well as delivering clean flue gas to ensure better heat transfer efficiency in the convective shaft of the system, resulting in high overall plant efficiency of the CFB unit. Question: how is the cyclone efficiency related to cyclone size? Answer: the basic cyclone theory suggests that as the cyclone size increases, the collection efficiency increase. Next question: why does collection efficiency increase with increase in cyclone size? Answer: because of the reduction in the centrifugal force separating the solids. Centrifugal force equal to mv squared by r, where m mass of the fuel gas burn particle kg, v or rho tangential velocity of the particles whirling in cyclone meter per second, r is radius of whirl m meter. Next question: why do large CFB units employ multiple cyclone arrangements? Answer: as the cyclone size increases, the collection efficiency increases with the effect. As the cyclone size increases, the collection efficiency decreases with the effect that a point in scaling up will reach ultimately where cyclone size gets too large, that limestone utilization and carbon burnout decreases. So large single unit employ multiple cyclone arrangements. Again I am repeating, as the cyclone size increases, the collection efficiency decreases with the effect that a point in scaling up will be reached ultimately where cyclone size gets too large, that limestone utilization and carbon burnout decreases. So large single units employ multiple cyclone arrangements. We will see next video further. Thank you.